We are in the Department of Chemical Engineering and Biotechnology, and one of our research themes is sustainability. In sustainable manufacturing, we are trying to exploit natural enzymes to design a new generation of catalysts that help us do difficult reactions in the lab in a greener way. In such way, we developed flavins that can be used to produce indigo dye or exploited in the range of reduction and oxidation reactions that can be triggered by light.
Enzymes are powerful catalysts that speed up reactions and drive numerous of biochemical processes in our body. And we want to harness their power to design a new generation of light-triggered catalysts to make chemicals using less energy, less solvents, and less toxic materials. And often we combine natural elements, for example, enzyme cofactors, with some nanostructured materials to enhance their catalytic activity and improve some other properties, such as recyclability, stability, and storage type.
Often we need to develop new tools to study the reactivity of these compounds. I work on these tiny optiflated hollow core fibers into which I mobilize flavins to quickly say whether they work or not.
We design artificial enzyme catalysts by using organic cofactor. We combine them with nanomaterials or slightly modify their structure. Basically, we look at nature, learn from it, and use a bit of chemistry to tune it.